Hello, everyone. Welcome to a new chapter. In this chapter, we will introduce sets and maps. Sets and maps are very efficient data structures. They provide constant time for the common operations for search, insertion, and deletion. The no-fly list is a list created and maintained by the US government's terrorist screening center of people who are not permitted to board a commercial aircraft for travel in or out of the United States. Suppose we need to write a program that checks whether a person is on the no-fly list. You can use a list to store the names in the no-fly list. However, a more efficient data structure for this application is a set. Suppose your program also needs to store detailed information about the terrorists in the no-fly list. The detailed information such as gender, height, weight, and nationality can be retrieved using the name as the key. A map is an efficient data structure for such a task. Let's look at the set now. This is the overall Java collection framework hierarchy for the look at the collection and the abstract classes. And this is the concrete classes. Here we have the hash set, linked hash set, and tree set. So we're going to look at these three sets: hash set, linked hash set, and tree set. The hash set extended from abstract set, extended from set, and extended from collection. The hash set defines the constructors. All the methods are inherited from the collection interface. Let's look at an example of using a hash set. In this program, we create a set of strings, add the strings into the set, and now use the for each loop to traverse all the elements and display the strings in uppercase. And this is to use the for each method from the set to display and all of these strings in the lowercase. Now look at the output now. San Francisco, Beijing, New York, London, Paris. In the program, we added New York twice. But in the set, it is only displayed once because the set does not store duplicated elements. All the elements are unique in the set. Now let's look at the linked list. The elements in a hash set are not ordered. It's in random order, not in any order. But the elements in a linked hash set can be retrieved in the order in which they were inserted into the set. Let's look at this example. In this program, we create a linked hash set. We add all the strings into the set. So please see the order. We add all the strings: London, Paris, New York, San Francisco, Beijing, New York. Now, when you display all of this using this for each loop, and you're going to see that this is the order: London, Paris, New York, San Francisco, Beijing. This is the same order they were inserted. Now let's look at the sorted set. And this is called a tree set. The elements in the tree set are sorted in the natural order and using the comparable interface, or in the specified order and using a comparator. This is the test program. In the program, we create first a hash set, add all the elements into the hash set. Now, this new tree set and a set is to create a tree set. And all the Java collection class has this constructor for collection. You can use a collection to create a new collection. So here we'll use this hash set to create a tree set. And now let's look at this, the printout. Now you're going to see this is Beijing, London, New York, Paris, San Francisco in this natural order. And you can get the first one, tree set dot first. So which one's the first? First one is Beijing. And which one's the last? The last is San Francisco. So this is going to be the last one. Let's look at another example, and we're going to use a comparator. We create a tree set and using the comparator. This comparator was defined in section 20.6 when we introduced the comparator interface. It's a geometric object comparator to compare the geometric objects using their area. We add this 4 geometric objects, and then we're going to print them out. And you can see this is the area here. So by area, so the area is 4, the area is 20, and the area is this number. And so those are all this displayed. Now you probably noticed that we have 4 geometric objects added, but why is it is only displayed 3? Because you added this same object. They're considered the same, the duplicates, so only one is displayed. So because they have the same area, so when you use this comparator, geometric object comparator, and so this is considered the same, so they're not stored the same. So only non-duplicate elements are stored. This is the example to demonstrate the performance between sets and the lists. And you can see this from this example, and set is very efficient for all these operations. Now, please note that the difference between these two data structures, set is more efficient than a list, but list has a notion of index. You can have very natural order, and you can say, I'm going to insert the elements at a certain index. But for the set, you cannot do this. So it's more efficient, but there are some operations and cannot be supported. And also, in this chapter, we have this case study on using set. This case study is to count the number of keywords in a Java source code file. Please read this example. We will introduce map in the next video. Thank you.